Welcome back to 5 Minutes Cloud. This is your host Sashank. Imagine you check into a hotel for a business trip. The receptionist hands you a key card and say, "Here you go. That's all. No explanations." Does it open just your room or it is going to give you the access of the gym? Can you enter the executive lounge? What about restricted floors? You'll not guess. You will definitely give it a try. Your room opens and the gym works, but the executive lounge shows a red light. Within few minutes, you clearly understand your access level. This is exactly how attacker treats stolen AWS credentials. If you remember in our previous videos, we are able to exfiltrate the AWS credentials against the roles when we abuse the vulnerabilities in the EC2 servers. So the attacker now has the access keys, secret keys, and possibly a session token, but they still don't know what these credentials are allowed to do. AWS does not provide a direct command that says, "Hey, show me all the permissions related to this access key." That means there is no simple API to list all the effective permissions of an IAM identity. So the attacker tests, they call the AWS APIs. If the call succeeds, the permission exists. If it returns access denied, it does not. This process is called IAM enumeration. First, the attacker configures the stolen credentials using AWS configure. Then they validate identity using AWS STS get caller identity. If this worked, then authentication is confirmed. But the authentication only proves who you are. It does not tell what you are allowed to do. To discover that, attackers generally make use of brute forcing the AWS API calls. And for that, there are multiple tools. And today we are going to explore Enumerate IAM. This tool automates permission discovery by targeting hundreds of AWS API calls. It tries actions like listing users, listing servers, listing roles, and a lot of other services. If the AWS responds successfully, that action is recorded as allowed. If not, then the action is recorded as not allowed. At the end, the attacker will get a list of confirmed permissions. This defines the blast radius of the compromised credentials. Now, to experience this, let's jump to my computer screen. This content is strictly for educational and awareness purposes. All attacks demonstrated are performed on self-created lab environments. Unauthorized testing or exploitation of systems without permission is illegal and unethical. The creator is not responsible for misuse of the information shared. Alright, so here is my screen. Here you are able to see that Enumerate IAM. This repository you will be able to see over here. You can get the steps of installation. You can just clone this repository, go to the directory, and then just simply do the pip install to install all the libraries required to run this utility. Along with that, I'll just give you a background check. I'm having an IAM user which is called Shashank, and this user is having a security audit policy, which is basic policy, which AWS recommends to perform any kind of audits. It basically provides you the basic read access around all the major services. Along with that, I am having access keys related to this particular user, which we are going to make use with this Enumerate IAM utility. And this we are assuming that these access keys and secret keys is something that we have already exfiltrated via the vulnerability in the EC2 like we did in our previous lab. Now this is my terminal. If you'll go back to my terminal over here, I am having this credentials.txt file where you'll be able to see exactly the same credentials, access keys, and secret keys. I'll quickly go to Enumerate IAM since I have already completed the installation steps. I'll just list it, and then you will be able to see that there is a Python file which we need to run or execute over here. Since it is a Python file, so I'll use the Python enumerate-iam.py -h to just list out what are the capabilities and how we can make use of this tool. If you pay attention over here, it requires input as access key, secret key, and the session token is optional. The reason is again optional. Since we have the access keys and secret keys over here, I'll just write access key, and then I'll paste my access key, and then I'll write secret key, and then I'll simply paste the secret key. And then if you have the session token, you can pass the session token. Otherwise, if it is just access keys and secret keys, add those and hit enter. What it does is it will try all the brute force technique. It will try each and every AWS API calls and try to identify whether I have the permissions to perform XYZ operations or not. Wait for a while and you will be able to see all the list of details over here. As you can see, it actually tried to identify what are the set of permissions that I have, and we'll see username over here, certain policies, then I'm having some username, again some other username, and then whatever the permissions that I have identified over here. So these are the set of things that it actually identifies. This JSON look quite noisy. At the end, you will be able to see some messages over here, and here you will get this line by line information starting from here that this credentials belongs to user Shashank. It is having one attached policy which is called security audit. Although this security audit has the permissions to list the user managed policies or inline policies, that is why it is able to list list out. If it was not, then it could have used some other API calls to list out whether it is working or not. Now, if you look at it, I'm able to check that, okay, EKS list cluster options available, Lambda options available, guard duty, CloudFront, each of these are possible over here. Since we already have this information, as an attacker, we can try to exfiltrate more into it. Once we are having the access, I can basically stop it over here. I will configure these credentials in an AWS profile. So I'll write AWS configure and I'll give it a profile enum-iam, and then I'll set these credentials so that I can easily try to access some of the services. Since I have configured on the profile enum, I can make use of to list out AWS IAM list roles, and then I'll add the profile, let's say enum-iam, and it's going to list me all the roles which are there in my account. Now, if I just wanted the role name, I can add the filter options over here. So let me quit it. I'll use the query option to filter out the results, and I just want the role name. So I'll write roles, and then inside all roles, I'm interested in getting the role name. So I'll just get the role names now. You'll see that these are my role names. This belongs to different services. Maybe some of them are like Lambda service roles, AWS service role for support. Using this, I can basically try to exfiltrate more options, and then I will be able to exfiltrate the details from the S3 bucket, or maybe I'll be able to perform some privileged actions like attaching the administrative privileges to the existing user or something like that. Now, you must have noticed something very important. Most identified permissions are read actions like list, get, or describe. But the question is why? Because the write actions like create user, delete user, or run instances actually modify the resources, and the enumeration tools avoid directly doing the destructive operations. They focus on safe read-based calls. But today I'm going to reveal a secret to you. There is a more advanced technique through which you can actually list out some of the write API calls without actually modifying the resources. Some AWS services supports dry run parameters. Using that, you can perform the write operations without actually modifying the resources. For example, AWS EC2 run instances with AMI ID and then dry run. If the credential has permissions to run the instances, it will return dry run operation request would have succeeded. If there are no permissions, it will return access denied. This allows an attacker to perform the write operations without actually modifying the resources. All of this happens using AWS API calls. No malware, no exploit code, just permission testing. So getting the AWS credential is only the phase 1. Understanding and mapping the permission is where real cloud impact begins. If you have learned something, just drop a heart. If you are new to this channel, just hit a subscribe button. Thank you for watching this video.